right? So to start this program agenda, I would start with this evolution of the cloud. So we'll try to understand how this cloud has been found, what this cloud is about. So we'll figure out how the cloud has evolved. It has evolved from the data center, as you can see from the first bullet point. We'll see how the cloud has converted infrastructure into a services model. We'll also have a glimpse of what types of services are being offered, and we'll have a glimpse of what it is in today's environment. How is the cloud being embraced? That's when we will get started with our cloud infrastructure with AWS. So we'll figure out what AWS has to offer for us today. What are the various services? After having a bird's eye view, we'll jump into the various services. As you might be aware, AWS offers more than 100 services, and it is impossible to cover all that even in a massive course. So we'll focus on a few services that all of us can relate and understand. So that would be the essence of the story. And then I'll give you a quick walkthrough of the AWS console, the practical hands-on part of the cloud. I'll also tell you some use cases who are using AWS Cloud at the moment. Right. So my assumption here is that all of you are familiar with the term data center. I'm assuming what a data center is known to all the participants, and from that assumption, I start the story. Data center, as you might know, is a place where data is centrally stored, be it a bank, be it any online e-commerce portal, you name it, and everyone have centralized their data, and the place where it is stored is your data center. So you have your servers, you have your storage, all your networking, blah blah, everything centralized in one place, your data center. Now what happened to this data center? The first step of evolution, it got virtualized. Servers were virtualized. In the sense, I don't mean that they became virtual. What I mean is one server was virtualized technically, and multiple servers were born in one hardware. We were able to install several server operating systems, several databases, etc. on one server. One storage box accommodated multiple virtual servers. One networking hardware was able to create a shared resource for several virtual machines, virtual storage boxes. And then came the converged and hyper-converged infrastructure. So the hardware also underwent a change, and we came to the new world of highly automated, redundant, converged and hyper-converged infrastructure. Add to that elements of automation and what we call orchestration. What we have is the cloud of today. So automation, several things are automatic. Some failure happens automatically, the failover happens. Orchestration, again, is much similar to your music orchestra, where your music director orchestrates the entire massive team to work as a single show. And that precisely happens even in the cloud. So selections are made, the orchestrator works behind the scene, runs several scripts, and gets the infrastructure up in no time. So what happens? We have services available for consumption. That is the cloud. So what was traditionally a hardware related stuff, what we used to talk in terms of infrastructure, today we no longer are talking as infrastructure. All this has been highly automated and made available as a bunch of service. So the modern data center has been converted into a bunch of services for consumption. So all I need to do is pick and choose the service of my choice and consume it as a consumer, as a subscriber. Okay. Now, if I were to implement the whole story for my own office, I call it a private cloud. And if someone like Amazon or Microsoft or Google do it for others to consume, then we have the public cloud. So today's story is about the public cloud predominantly, AWS in specific, but cloud is the same. It's private if it is belonging to me, consumed by me. It is public if it belongs to someone, consumed by others. So having a glimpse of the services that it offers, most of you would be familiar with the basic services which we call the IaaS, or Infrastructure as Service, PaaS, Platform as Service, SaaS, Software as Service. But that's not the end. That was the beginning. These were the three starting points for the cloud. Three services that were offered as consumption. Whereas today, that is being further divided, further offered as several host of services. Storage as service, database as service, function and service, so on and so forth. What we have today is a phenomenal bunch of services, right from infrastructure up to software and several stuff. It's easy for us to understand that. At Office, we may be using Office 365. What used to be the MS Office installed on computers, today is cloud-based Office 365. Most of us will be using your OneDrive or your Google Drive. Most of us will be using the Google Sheet or Google Docs. There is software as service, storage as service, all these and much more. So today, the cloud has made everything possible to be offered and consumed as service. I request you to make an easy comparison to the old days where we used to have a TV, a home theater, a DVD player, all of which was required to play a high definition movie. But today, you subscribe to the Dish TV network or the Internet TV, and that's it. We're able to watch dime a dozen movies, and at a fraction of cost. That is precisely happening to the IT infrastructure space, thanks to cloud. So what's the scenario today? What are the biggies doing? Are they working with only private cloud? Are they having just about their own internal data center? Or are they working with public cloud? It's all of them. It's not about one of them or a couple of them. It is about all of them. Most of the Fortune 100 or Fortune 500 companies have their own databases. Most of them have an implementation in the public cloud. Most of them have connected both of it in the format of hybrid cloud. Most of them have interconnected to several of the public clouds. The multi-cloud hybrid cloud, that is the reality of today. Gone are the days where we were choosing between the on-premises data center and the public cloud. Today, it is multi-cloud, inter-cloud, hybrid cloud. That's the story today. Okay, so with that brief introduction, let's try to understand the infrastructure, the services. Let's try to get into case study based understanding of how AWS plays a very, very important role today for us. But to start the story, let's have a glimpse of how AWS is organized. How many data centers it has? Where all does it have? can some individual match it? So this particular slide gives you a glimpse of the whole story. You can look at how many locations it has got its data centers. And this is counting. This is not a fixed number. It is counting. You have about 24 regions, and this is as of January 2020. Half year has crossed, and they would have completed one or two more. So across 24 locations of the world, it has caught about more than 76 data centers. You can see the slide, it reads 76 availability zones, which means each data center will also have one or two backup data centers. So an availability zone literally means more than one data center per location. So if I say 76 availability zones, the least number of data centers being 2, I have 150 plus data centers distributed across 24 regions across the entire globe, which you can watch and see the blue and orange dots. And what do you think would be the size of a data center? Anywhere between 50,000 to 1 lakh servers. That's the number of hardware you find per data center on AWS. So that's quite a bit. Mute yourself, please. Okay. So like I already mentioned, it is not about just the hardware being available. It is about how the cloud service providers have automated, have scripted, orchestrated, and made available so much of what they have as a bunch of services. As you can see, you have a bunch of servers, a bunch of networking components, mobile related services, storage, so on and so forth. And on the right, you can see the core infrastructure services apart from several other services. The listing under each of the headings that you see is the names of various services that you come across in AWS. I'll be sharing a document for all the participants which lists all the services and their functionality in brief. That would be part of the documentation that would be shared after this particular session. Okay, so what I'm going to do is I'm going to jump into the more interesting part, the more specific part. The assumption is that I'm going to take you through a story where we decide to embrace cloud. My company or your company says, hey, I want something up, fast and running. I can't give you a great budget. I can't give you much time. You can't have time to place an order for hardware, order for software, pay licenses, install every stuff. I don't have so much time. I want you to quickly enable a server, put it on the internet for everyone to access. That's the ask my company gives me. And it says I don't have a huge budget, but yes, whatever you put it, whenever you get it ready, I'm ready to pay a rental cost. And when I say shut it off, you'll have to immediately shut it off. What do? I jump onto the cloud, the public cloud, and in today's case, the AWS cloud. That's precisely it. I don't have to buy anything, no licenses, nothing. I just go over, open my account, provide my credit card details, and that's the assurance I give AWS that whatever I consume, I'll pay for it. Much similar to paying in a restaurant or much similar to pay our cable TV service provider. So let's start the story. Let's assume I want to go in for a single server. I'm going to do a test run. So I want to go for a single web server. I'm going to host a bunch of things and make it available to users on the internet. So I want it quickly provisioned. I don't have much time. So I tell my company, hey, I have this service provider here. He calls himself AWS, and I'll give you what you want. I'll provision a web server in probably the next couple of hours. Account open, provision goes live on the net. So that's the speed of getting things ready when we embrace cloud. Now, many of you might already be contemplating, many of you might already be guessing why startups are coming up in dozens. This is the prime move. Startup company which has an idea, which does not have the wherewithal, money to set up an infrastructure. The public clouds have come as a beautiful boon. They put their idea on the cloud in no time and just kickstart their operations. Done. So I go to the cloud, I select the web server of my choice and tell it, hey, provision me. It gets it ready in no time, and the next half an hour my story is ready. Whatever installation, whatever application, whatever code I want to put, I take a couple of hours, put it there, connect it to the internet, and announce it to the world. Done. So what happens? I've got an excellent product. My company has an excellent product. This is very well received. So the crowd increases. Looks like this single server story is not going to be sufficient. So my company tells me, hey boss, looks like your server is running out of space. We want to increase features. We want to convert that into an e-commerce portal because we want people to pay up for whatever we were offering free. So I tell them, no worries. I'm going to help build an e-commerce portal, but as you rightly guessed it, it's not going to work with a single server. I'm going to implement what is called a multi-tiered e-commerce portal, which will combine 3 different servers. I'm going to have a web server which takes all the internet user load. I'm going to have an application server which does all the work, the business intelligence part of it. That's going to get connected to the database, which is going to hold all the information about the users, their account details, the payments they made, so on and so forth. Yes, boss, your multi-tiered portal is ready. So what I do? I provision this in the next several hours or probably 1 or 2 days at best. Imagine doing this in real time. I need to be ordering hardware, I need to be ordering software, the licenses, the costs, all is going to take months. What was going to months is now hours and days. That is the go-to-market advantage that the public cloud offers. Right. This also did not suffice. Immediately, the product has been so good that the management has said, hey boss, not sufficient. We'll have to go in for an expanded version of what this is. We're seeing increased load. I said, fine. We'll increase the number of servers. No worries. I'll increase the number of web servers, application servers, databases based on the load. But then, what do? I bring in the load balancer because I'm going to have more number of servers. So all the requests go to the load balancer. The load balancer figures out which server is free, forwards the request to the server that is free. So is the case that happens with the application servers as well. And when my product range offerings expands in my portal, I also need to go in for different types of databases. While the RDBMS, the database server, is going to hold all user information, my NoSQL is going to hold a lot of non-user information as well, which could be about the products, the vendors that I register, so on and so forth. Imagine a Flipkart or a Snapdeal or BestBuy.com or whatever, online purchase portal. So they'll have several vendors registered with them. They'll have all the products with them, so on and so forth. Those details, vendors and product details, will be stored in a NoSQL database. So I have different types of databases also now. All right. There are several images, several pictures to be shown up. I go to Flipkart, I go to Amazon.com or Amazon.in, I browse for details. I want to buy something. I want to buy a new mobile phone. I go to the mobile phone sections. There are dime a dozen vendors, hordes of products, models, pictures, thumbnails, expanded version of the pictures, all of which go into a object storage. So all the objects, the images, the pictures are in the object storage, and the application servers picks up all the relevant data from here, throws it up to the users who then access it. So look at the transition. As the load increases, dynamically I'm able to reprovision quickly in hours or days. Right. Now, next, let's put this in perspective. Let's try to understand the same story in AWS language. What do? I, as an AWS administrator, will create my own virtual private cloud in the AWS. When I create my virtual private cloud, it allows me to create one or more networks in my private cloud. This private cloud, as the name suggests, is available completely under my control. Nobody has access to it other than me. So what do? I create one or more subnets or networks within my private cloud. I provision my server, the web server. AWS calls it the EC2 or Elastic Compute Cloud. That's the name given by AWS to the virtual machine that is provisioned inside the AWS cloud. Okay. So how is this made available on the internet? It is made available on the internet through the Internet Gateway. So you have the Internet Gateway that provides connectivity for the internet users to access the web server and vice versa. Okay. So when my system's infra expands, I have EC2 instances and database instances. I would like internet users to access only my web server and not my other servers. My other servers are required to be accessed only by my own web server. So what do? I create different networks, configure one of them for public access, the public subnet, and put the other servers in a private network, which means only internal access is allowed for security purposes. The internet users have no access to these guys. So what do? If I have several networks, I need inter-network connectivity to be happening using the router. So my virtual private cloud with different networks will have a router which interconnects all of them. And the public network alone will have connectivity to the internet using or through the Internet Gateway. Okay. Now if I want to run some downloads on this application server or the database, then these guys need to access the internet. The internet users will not be able to access this, but these components must be able to download stuff from the internet, and so I will give a separate exclusive access to the internet through something called the NAT gateway. So the NAT gateway will be connected to the internet and will allow your databases, your application servers to use it and download from internet. That's only for getting inputs, getting stuff from the internet for its own use and not for these guys to access here. That will be prevented, not allowed. Okay. So we have seen the network components now. The VPC, the subnets, public and private, the internet gateway, NAT gateway, and your router. So these are all the network components of your AWS cloud. See how quickly you have understood so many things. What you might have understood over ages in a traditional environment, traditional network, you understand stuff so fast. And if you learn AWS, you implement stuff equally fast, as I'm going to show you. Okay, I said when you have multiple servers, we're talking about load balancers here, different types of load balancers. What are they called? Elastic load balancers or ELB, ready-made available. I just drag and drop as I am doing a cut and paste. I provision a load balancer, put the servers behind. That's it. Whatever traffic comes, hits the load balancer, it divides the traffic between these two services. Done. So example for a typical RDBMS is called RDS in AWS. Another example for NoSQL is called the Dynamo DB. There's a host of database services. I'm just taking one example each. Okay. Having touched upon the network components, the virtual machines, load balancers, let's try to understand a few more concepts. There could be one common question arising for all of you, many of you. Is it secure? Can I put so much stuff on the public cloud? Yes, it is secure. Let's see how the security works, what all has been going in. First, nobody has access to the private cloud that I've created, not even AWS. It allows me to create the private cloud and only I, the administrator, enjoys complete access as to what I do here. So what I get as an administrator is the console access. I enjoy full permission. And if my organization is huge and I have sub-admins under me, I'm going to create sub-admins. A network admin, a storage admin, a computer admin, a backup admin, so on and so forth, and allocate them permissions. So security is ensured as far as user access is concerned. That means a user is authenticated with multi-factor authentication, is authorized to perform some functions. Then he can also authorize, or I as a console admin, I can also authorize a developer who is building applications on my servers. So this developer will be assigned programmatic access by me. So the developer would be able to access the servers directly because I've got a dedicated connection from my office to the private cloud, which is called the AWS Direct Connect, and he's able to securely access and do whatever he wants, deploy the new applications on the application servers. Okay. So once the setup is ready, production is on, I need to constantly monitor what's happening. So that's an inbuilt monitoring tool. That monitoring tool captures all that is happening here. It captures live, it captures alerts, if there is a breach, if there is a threshold which is crossing, utilization goes high, whatever it is, the alarms are sent, and the monitoring logging component captures all that detail. And it doesn't stop there. This guy can also automate certain stuff. Okay, what is that? He figures out from this data that some utilization seems to be high, data loaded into the database is very high, etc. I write a rule, tell this fellow to raise a trigger. What does that do? Hey, sufficient data has been stored, you need to take a backup, right? So now this guy sends a trigger, sends the trigger on a queue, and there's a serverless component which resides in the AWS. So it sends the trigger and it immediately starts taking backup of whatever you have specified. So the backup gets automated. So look at how everything works together. It's secured, it's monitored, and automatic, scripted, automated activities are taken out. So that's about an automation also that we have seen here. Okay. So what are the components which help us execute all this? It is the AWS IAM, Identity and Access Management, which handles the security. I have not spoken about how secure, how compliant the whole system is. That's another story for another day. And we have this component called the CloudWatch, which is responsible for monitoring and logging. You can also configure to trigger taking up of backups. The trigger can be queued, sent to the program executor, which is the serverless computing of AWS called the Lambda. And the Lambda takes a backup, which is technically termed the snapshot. All these are the AWS components. Okay. So let's have a look at a few more components. Let's assume we have a case where there are users from different countries, European countries, American countries, Asian countries, etc., trying to access. And my company is into, let's say, the insurance domain, or it's into some kind of a financial domain. So you must have heard of HIPAA compliance, GDPR, so on and so forth. So what happens is these countries warrant all the user data to be present in their own countries. So that means I cannot have or I cannot host a server in AWS Cloud in North America or India for European users. I must have servers in Europe for European users. I must have servers in America for American users and store their data locally, provide data to them locally. That's basically what is achieved by a component which handles the traffic in Amazon, which is called the Route 53 Traffic Manager. So what I do? I don't have servers in one place. I deploy servers in multiple places. The same portal which I had built, I build it in Mumbai, I build it in one of the European countries, and I tell this component of AWS, hey, whenever there are users from the Europe, please divert them to the Ireland set of servers. Elsewhere, please divert them to Mumbai. So that is taken care by this guy. Now my company, my product offering has grown leaps and bounds. So what happens? The traffic seems to be bursting in seasonal times, peak hours. Let's say peak hour of the day, 9:30 to 12:30, immense traffic. And after that, slightly less. Night times, no traffic. So it is costing me huge to have too many servers. So what I do? I set up another automation here on the web server part. That automation is called the AutoScaling group. I want to have 2 servers all right by default, but if the traffic increases beyond 50%, automatically add 1, 2, 3 more servers. So minimum there should be 2 servers, maximum there should be 5 servers, so that it bursts whenever required. When the load goes down, automatically it shrinks back to just 2 servers, all by itself. So that's called auto-scaling. So that is a built-in feature. I just need to configure that. In no time I can do that and see what scalability we have. We have compliance, internal traffic management, load balancer manages traffic within this location. Auto-scaling handles increase or decrease in traffic by optimizing cost, all of which happens in the same environment. I don't have to keep investing in all these components. I just pay as we go. Whenever there is any server that is added or reduced, I have configured to send a notification, and there it goes. The notification is sent to the admin or whoever I configure. That's it. Automated. So all this in a quick amount of time. So the notification service is called SNS. The traffic manager here is called Route 53. These are again the AWS components. So I'm briefing parallelly the various AWS components that you would come across when you're implementing such stuff in your organization. Okay, there are going to be other components for managing workflows. You can do it on the AWS, or you can also do it on your premises. What is a workflow? Workflow is like you have a multiple set of tasks to be performed independent of each other, one after the other. Let's say I'm going to have a video shot, and this video I'm going to convert. I'm a short filmmaker. I convert this video in different formats and upload it on YouTube. I distribute it on your Apple iTunes or wherever in different formats. So I need to immediately convert into different formats. I need to have my IP, the digital rights, sealed on these videos and then released. I can go take the help of simple workflow service and tell it, hey, use the transcoder to create multiple video formats. Use the built-in DRM modules to do the digital signature part. And then once it is ready, release it on all these platforms. All can be done. Okay. So let's say I'm putting this on my server, and my server is in one location. Everything is ready, quick, in no time, but my users across the globe have started complaining. Hey boss, your performance is slow. You have put your server in Mumbai and Europe. I am sitting in Australia. The performance is slow. Why don't you do something? Yes, AWS has got a solution, the CloudFront. What it does, it picks up this particular video on the server. It has established a worldwide caching network, sends it across to all the edge locations. Australia, we saw some 76 plus regions. You have much more than 76 regions for caching. This fellow sends across every place in the world, and the users will now fetch all that information from their local CloudFront cache. So what happens? Globally, the performance goes up. So look at that. You not only have the infrastructure, you not only have the services, various services for you to use up, you also have a phenomenal caching network built in. It depends on what you want to use, what you want to leverage for your organization. And the ultimate part, the latest, and I'll promise you this is the last of the theory. We'll jump into the labs after this. Devops. So this speeds up the entire development process. This defines the development framework for all of those who are looking to get into this segment. DevOps is a common term which is for both the guys who are going to build and maintain your infrastructure as well as the developers who are working. A lot of cloud native development is happening. Why is that so? We saw some time back a component called Lambda. It can execute on your behalf. So what happens? You don't have to build infrastructure to run your Python program, your Node.js program, your Java program, your C# program. Just leverage the available serverless execution engine Lambda. Similarly, those of you who have heard of the Docker's containers, those are also built into the cloud. Microservices. So you can have, let's say, 10 programmers developing a software application. Today, they don't develop a monolithic application if it is huge. Each of them develop one small component. A single user interface integrates all of them to showcase as a single application. So each of the 10 components constitute your microservice. And a microservice, for all you know, can leverage and use your Lambda function. The containers may be used or the virtual machines may be used depending on the load, depending on the ask. Parallel development can happen. Continuous integration can happen. Continuous testing can happen. Whenever there is a change, whenever a new feature is added, that particular programmer alone can add that component, commit that code. The code builder will build whatever needs to be released. The testing component will test it. Your integrator, the continuous integration code pipeline or Jenkins or whatever be the component, will ensure that all these are integrated, tested, unit-wise tested together, prepared for release, staged, deployed, monitored, feedback given. If there is an error, change is done, the entire story happens. Everything happens on the cloud itself, for the infrastructure, for the application, right? So all the components that you will require to ever build an entire story independently, pay-as-you-go model, happens on the AWS cloud. One fine day, the business decides that no, we no longer want this portal, shut it down. We're going to divert our business. We're going to shut this arm. Fine. Destroy it at one go, bid buy to AWS or any other cloud for that matter, and you don't have to pay up anymore. So look at the kind of business support that they give you. Needless to say, everything has a guaranteed uptime. 4.9 uptime, 11.9 availability, so on and so forth. Phenomenal service levels. Want to understand who uses this? Some of the familiar names. If you've been watching a lot of Netflix movies, be assured it is from the AWS. Several services of AWS are being used. Some of those which we discussed now and a couple of them which we didn't is listed here. We have been using the storage service Dropbox. Yes, it's on AWS. The most popular storage S3, a simple storage service. NASDAQ, to store its humongous data, makes use of the AWS warehouse, Redshift, the Airbnb, the travel, which is the number one in that space, uses AWS. The Shell Petroleum uses AWS, and G3Ms for some of their verticals, some of their divisions, they make use of AWS. They are migrated to AWS. That's a short story about the AWS, why it's required, what services you have on offer, right? And this is where I get the listing of services. So you can see whatever you saw in the slide, this is the bunch of services, 100 plus services that you have. And you can see that there is something called as the VPC or the virtual private cloud. I've already created, there is something that already exists here. I'm not going to spend too much time on that. Whatever exists, I'll show you what exists. So I am now going to do everything in Singapore. You can see the Singapore region being selected. I have two VPCs here, one which AWS gave me by default, another which I created myself. And I also have some networks created, public 1, public 2. I have created a couple of networks. I've also created public network, private network, so on and so forth. These three are in the default virtual private cloud, and these two are in the virtual private cloud that I created myself. You have the route tables where the configuration happens for all these. You have the internet gateways which are connected to the VPCs. You have NAT gateways, so on and so forth. So what about the servers? The servers are called virtual machines, and AWS calls it the Elastic Compute Cloud or EC2 instances. So I go to the section. I do not have any EC2 instance. So I'd like to build a scalable model. So what I want to do is I don't want to have a single EC2 instance. I want to have one instance to start with, and it should automatically add up multiple instances on demand. So what I do, I go to AutoScaling groups, right? And the AutoScaling group is where I create a policy and virtual machine. Let me say I want to call it the AutoScale group, where I would like to start with one server, which means I say that it has to be with one EC2 instance. I would like to put it in my default virtual private cloud, and I would like to put it in my pub 1 availability zone. Maybe for redundancy, if I want to put more, I can put it in the second also. I choose two networks, but now since it's a demonstration, let me be happy with one network in this private cloud, and I would like to launch an automatically scaling out, scaling in, auto-expandable group of EC2 instances that starts with one instance. Okay, so what I tell, I'm going to define that it is going to scale between a minimum of one EC2 instance and maximum of say 2 EC2 instances. I can say 4, 5, 10, whatever. I can say minimum is 5, maximum is 50, whatever I want. Okay, but since this is a demonstration, I say I'd like to start with one EC2 instance, let it scale to maximum of 2 instances. So I'm controlling my costs as well. I don't foresee a load beyond 2 instances. So I say this is what I want. Okay, what should be the metric? When should it be 1? When should it be 2? I would like to start with 1 and add up one more instance when the average CPU utilization is going to be say 50%. I'm going to give it some warm-up time, let's say 45 seconds, and till that, whenever you are increasing or decreasing a virtual machine, inform the admins. So I have given my own mail ID here, rjpvijay@yahoo.com. I would like to send a notification mail because once I've provisioned, I'll go have my coffee, I'll be off office hours, I'll go home, so on and so forth. I'll be watching my mail. Some trigger happens, I'll get it in the mail. Immediately I'll know that something has happened. Done. Okay, if I want to add some name, let me say AutoScaling RJP, or I say key is just say name, and I say AutoScale RJP, and I'm ready to launch. So what happened is earlier, one step which I did not show you is the selection of the server. I had already made a selection of the server in a template. It is a Windows 2016 server. So once I have defined that template in this autoscaling group, I have defined the autoscaling policy. I would love to see how many instances it is provisioning. I told you that initially the number of EC2 instances should be 1. Desired is 1, minimum is 1. And if the load increases, it goes to 2. So that is what we are going to now experiment. So when I launched it, it is launching with 1. It is provisioning this. I can also go to the EC2 instances and see that it is provisioning that particular instance. Right? So it is still initializing. Let's wait. See how fast it is doing. It was not there initially when I showed the instances would have been empty. Now it is provisioning one EC2 instance. That means buying the hardware not required, buying the software not required, installing the software, and then provisioning it, connecting it to the internet. Everything is over. So quick. Let me refresh to see. We'll just have to give it a couple of minutes. And how do we connect? See, I'm just showing you the console on the AWS. I'm telling you that this is a Windows 2016 machine. But how do you trust me? Okay, I can show you. It shows Windows Server 2016. All right. But how do I access this? Now, sitting at my home, if I want to access this, I will have to do a remote desktop connectivity. Okay. How do I do that? This guy will have a public IP address, which is shown here. So using this IP address, I will do a remote desktop connectivity. And I click connect here. It shows me the password. It asks me to decrypt the password. I've already chosen a file. I've kept it ready. I'm not walking through all those procedures for one of time, of course. I decrypt the password, copy that, download the remote desktop file, and watch if it is over. When it has completed the status checks, it indicates that it is ready. The Windows Server 2016 is ready for me to access. I click on this RDP or remote desktop, connect to the remote desktop, supply the password, and here you go. My Windows is being accessed. The last 5 to 10 minutes I have demonstrated how an administrator can quickly provision a scalable Windows server right in front of your eyes. Once the desktop comes up, I am going to show you how quickly I increase the load on this, and I will also show you how the second instance also gets triggered. Okay, so here is my Windows 2016. It is up and running. There is a file or there's a program which I'm going to copy paste here. And as you can see, the name is CPU busy. and this fellow exactly does what it says. It's going to get my CPU busy quite fast. Let me see what has happened to the CPU utilization on this machine. Look at that. CPU is hitting 100% load. So I have simulated a high load on this particular EC2 instance. Now I'm going to go back to my screen and I'm going to watch what happens there. So you'll have to wait for some time because that 50% load will be tested over a certain period of time. So we'll have to give it that time. So if the trigger happens, we'll be able to see that it has triggered, it has crossed the average 50%, and so it will trigger the second instance. So where do I watch that? I can go to Cloud Watch. And you can see that there is something, it has not gathered enough information, so it says insufficient. So we'll have to be a little patient. CPU utilization less than 45 for 15 data points. So it is well within the limit as of now, right? So it looks like it is going to trigger things. CPU utilization greater than 50 for 3 data points. Okay, let's wait till this alarm hits. I hope it is firing. Yes, it is firing. So since it's going up and down, let's see what happens. Still says insufficient data. So the average has gone down. So let's wait. Let's wait. So you will see that it shoots up. Or I should have reduced the threshold. Maybe 50% is a little high. I should have kept it at 40, 45 so that it had fired by now. So you'll have to bear with me so that the magic happens. And it will be really interesting to see the magic happening. Oops. So let me go back to the AutoScaling part and probably change some parameters to suit our convenience for the moment. What I'm going to do is I'm going to reduce this to maybe say 10%. Right? So now let's see what happens. Okay, instanted may be in the process of launching or terminating in order to match the desired capacity. Try refreshing the table. So desired is 2, instances is 2. There you go. So I go back to the instances. Now I'll be able to see that the second one is automatically fired up. So the second one is initializing. I hope you enjoyed the magic. Right?